Okay, here are our two equations. You have 2x plus y equals 6, and then you have 3x plus 4y equals 4. Now your goal is to figure out which one is going to take the least amount of work in order to get it in y equals something or x equals something. Let's look at the one on the right. If I were to solve this one for x or I were to solve this one for y, look at the information I would have to do. I would have to move, let's say I wanted to get the y by itself. In order to do that, I would have to move the x and divide by 4, and you are going to be left with ugly, ugly fractions. So don't do anything that's going to require a whole lot of headache for yourself. If I look at the equation on the left, in one step, I can get that equation in y equals whatever I want it to be. And it doesn't require fractions or anything else. So let's do that one, okay? I'm going to take this equation, I'm going to solve it for y, and I'm going to do that in one step by moving 2x to the other side. And that gives me y is equal to negative 2x plus 6, okay? Doesn't that look like y equals mx plus b? If I wanted to graph that, I could, but why am I going to graph that? I can use substitution. So I'm going to take this information, now that I know what y is equal to, and I'm going to substitute it right here in place of this y, okay? So find which equation is going to require the least amount of work to get either x or y by itself, okay? It doesn't matter which one you do, it just matters who requires the least amount of work. Once you do that, now it's all about substitution, which we did the other day. So we have 3x plus 4 times y, and let's substitute in purple today. Negative 2x plus 6, there's my substitution, is equal to 4, okay? Now if you look at the equation, you have an x here, you have an x here, and that's the only letter you've got. When you're solving equations, you can only solve for one variable at a time, which is our whole reasoning behind doing substitution, plus another method I'm going to show you today, which is elimination or addition method. You can only do one at a time. So once I do my substitution, then it's distributive property. It's the same old song and dance that we've been doing. Distribute, collect like terms. This would make 4 times negative 2 is negative 8x. 4 times 6 is 24. And that's 4. So I distribute. I'm going to collect like terms, which would be those two because they're both x to the first power. So that gives me negative 5x plus 24 equals 4. Move the 24 over to the other side by doing the opposite, which is subtraction. And that's going to give me, let's see, negative 5x is equal to negative 20 because the 24 was bigger, so it's negative, okay? And then I'm going to come way up here just so that you can see it a little bit better. And I'm going to have negative 5x is equal to negative 20. And then I'm going to do my last step, which is division. So divide by negative 5, and I get x is equal to a negative, divided by negative is a positive. So x is equal to 4. So that's the first answer. That's half. So if I write that over here, let's see. X is equal to 4. That's the first half of my ordered pair. Because remember, when you're solving systems, that's what you're looking for. You're looking for an ordered pair, okay? That when you were to graph these two lines, they would intersect at whatever this ordered pair is going to be. But now that we know that my x value is 4, I'm going to take that 4 and I'm going to now substitute it back in place of this equation, the y equals negative 2x plus 6, and I'm going to solve for the other letter that I need. So I have y is equal to negative 2 times x, and I'll do this substitution in red just so that you can see there's a difference, plus 6, okay? And then I do order of operations. Y is equal to negative 2 times 4. That's multiplication. That goes first. So that's negative 8 plus 6. So y is equal to negative 8 plus 6. When you do that, that gives you negative 2. And there's your final answer. So positive 4, negative 2, that is your ordered pair for this solution, okay? All right, that's all I have for substitution. Come back because we're going to learn one other method, which is, I think it's easier. A lot of people think it's easier than this, but you know, it just depends on your preference, okay? So come back so I can show you that new method.